Hello. So in the last couple of videos, we've been sort of proving the derivatives of certain trigonometric functions using only the definition of a derivative with limits. And so like in those videos, which I hope you've been enjoying, we're going to be doing the derivative of tangent of x, which I believe I covered in the useful derivatives video, but if not, it's here. So our function f of x is equal to the tangent of x. And by the definition of the derivative, the f prime of x, the derivative of that function, or any function, is going to be the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. All right. But in the case of this function, f of x is tangent of x, so we can write it out instead as the derivative f prime of x of our function is the limit as delta x goes to 0 of the tangent of x plus delta x minus the tangent of x over delta x. And this is going to go pretty similarly to the other videos. What I'm first going to do is separate it out tangent of x plus delta x, which from trigonometric identities should become the limit as delta x goes to 0 of, well, what is that going to be? It's 2 tangents. No, right. Sorry, I mixed that up with something else. It's the tangent of x plus the tangent of delta x over 1 minus tangent of x tangent of delta x. Okay. So that's not the most pleasant thing we've ever seen, but it's not terrible. Now we're subtracting tangent of x and dividing by delta x. Okay, now what I'm going to do is make some like denominators inside of the numerator here. So I'm going to turn this all into one fraction up here. I'm going to write this out as the limit as delta x goes to 0 of, let's see, we have tangent of x plus tangent of delta x over 1 minus tangent of x times tangent of delta x minus tangent of x times 1 minus tangent of x tangent of delta x. This is already getting pretty ugly. Over 1 minus tangent of x tangent of delta x. And then all of that is still being divided by delta x. I'm going to have to erase some stuff to make room, but I think everything should be fine. So let's combine these. This is going to be the limit as delta x goes to 0 of, and I'm going to distribute this out as well in the process, the limit as delta x goes to 0 of tangent of x plus tangent of delta x, oh, there's a dog barking, minus tangent of x plus tangent squared of x times tangent delta x. Hopefully the dog gets tired of barking eventually. Divided by, well, we can really combine this delta x with these terms down here. It's going to be delta x times 1 minus tangent of x tangent of delta x. Okay, so this is not really a super pretty thing, but we can work with this. First of all, we have tangent of x here. Here I'm going to we have tangent of x here and tangent of x here, and we're subtracting it, so these are going to go away. So that's a little bit of a helpful simplification. Then all we're left with is these two terms here, tangent squared of x times tangent of delta x and tangent of delta x. So what I'm going to do is say that this is equal to the limit as delta x goes to 0 of tangent of delta x times 1 plus tangent squared of x divided by delta x times 1 minus tangent of x times tangent of delta x. Okay then, so there's another way we can simplify this, and I'm obviously going to have to erase some of the stuff here. So I'm going to just erase this part. In fact, I think I'll erase, I think you've got this. You can always go back earlier in the video if you missed some of that. But we're left with this part down at the bottom, and we're going to transform that a little bit further. Now then, we're going to use the same little trick that I used in the other videos, and that is this one kind of a limit identity for trig, that the limit as x, in fact, it's not the best place to write that actually. Where's a better place to write that? Yeah, I'm not going to find a better place. The limit as x goes to 0 of sine of x over x is equal to 1. This is a very important identity when you're trying to do problems like this. And we've done it in the other two videos, but it's also going to appear in this video. But how so? Well, let's see. What I'm going to say is that this limit here, by the limit properties, is going to be the same as the limit as delta x goes to 0 of tangent of delta x divided by delta x. Ooh, and maybe that's interesting to you. Times the limit as delta x goes to 0 of 1 plus tangent squared of x over 1 minus tangent of x times tangent of delta x. Okay then, so where is this all going? Well, there's another interesting identity that isn't really related to limits, but is also going to be used. This is one of the Pythagorean identities that says that tangent squared of x plus 1 is equal to the secant squared of x, or 1 over cosine squared of x. This is one of the this is just a rearrangement of the Pythagorean identity, where we say that sine squared plus cosine squared is equal to 1. Here, what we're doing essentially is just dividing by cosine squared on both sides of that original equation, and we get this. So this is it's a very simple identity. Whether or not you've seen it before, it can be derived very easily. So now then, what does that mean? Well, that means that we can turn this part up here into secant squared of x. Alright, and I'm going to do one other thing to this other part. Over here, tangent of x is the same, we're going to say this is sine delta x over cosine delta x. Right? It's just two little simplifications that we're doing. Limit as delta x goes to 0 of it's sine delta x over delta x times cosine delta x. Notice that these are the same expression. All I've done is turn tangent of delta x into sine of delta x over cosine of delta x, and then put the cosine of delta x and the delta x together. Okay, now then, that's being multiplied by the limit as delta x goes to 0. And this is probably my favorite of the three functions to find the derivative of using this method, just because I think that it works out in a bit of a more elegant way than the others. So this is going to be the limit as delta x goes to 0 of secant squared of x over 1 minus tangent of x times tangent of delta x. Okay. One final thing before we can solve. All I'm going to say is that I'm going to take this one on this side and break this up into two parts. So let's actually do this with a different color. Let's do red. So I'm going to take this part here. I'm going to pretend this is red. There we go. And I'm going to say that that's equal to the limit, and this is again just using limit properties that we can separate out factors. This is the limit as delta x goes to 0 of sine of delta x over delta x times the limit of 1 over cosine delta x as delta x goes to 0. Right? That's all we're doing. I just took out the 1 over cosine of delta x and the sine of delta x over delta x, and then we're multiplying this whole thing by our green part, which is the limit as delta x goes to 0 of secant squared of x over 1 minus tangent of x, tangent of delta x. Tangent of delta x. There we go. Okay then. So there's essentially just one more step, and to get there I'm going to have to remove our little expression from earlier. Here we go. There are some ways that we can simplify what we have here. So what is this here? Limit as delta x goes to 0 of sine of delta x over delta x. Well, delta x is just a variable like the one up here. It doesn't matter what we call that thing that we're taking the limit of, and that's in the function sine of x and x. Limit as x goes to 0 of sine of x over x is the same as limit as delta x goes to 0 of sine of delta x over delta x. They're just variables. So this thing just equates to 1. Just like up here. This is 1 okay, there's really no point in writing 1, but I will anyway. This is 1. This is all just a big 1 here. Hopefully you can see that. Alright, what else can we say? Well, as delta x goes to 0 here, cosine of 0 is 1. So this thing also turns into 1, right? 1 over 1 is 1. So this is also a big 1. So right now we have 1 times 1, so those two things on the those two expressions that we had there ended up not really changing anything, right? So all that our answer is going to be is this thing over here, and there's a way that we can simplify this. Just plug in delta x for this expression here. This thing down here, tangent of x times tangent of delta x, right? Here. Well, the tangent of delta x as delta x goes to 0 is just going to be 0, right? The tangent of 0 is 0. So this whole thing is just going to disappear into 0. And we get the limit as delta x, well, this delta x, we've seen what happens when delta x goes to 0. So our final answer, because this goes to nothing, and we get secant squared of x divided by 1, or secant squared of x. Because as delta x goes to 0 of secant squared of x, nothing changes because we're talking about as delta x goes to 0 and delta x has nothing to do with x. Like if you say the limit of x as m goes to something, it's meaningless. It's just x, right? Because we haven't made any kind of comparison between x and delta x. So in this case, we're going to get that our final answer, given that f of x is tangent of x, f prime of x, the derivative of that function tangent of x, is equal to secant squared of x. And that's kind of funny. That's kind of interesting, and it'll be interesting and quite useful later in integral calculus, which I'm not going to get that much into now, because tangent squared of x plus 1, this thing up here, which you can kind of get by manipulation often with sine squared of x plus cosine squared of x, or whatever variable you're using, which can easily come from 1, is also the derivative of that function, which, as you see later when you're doing like u substitution or trigonometric substitution, can be very helpful. But enough on that. I hope that this was entertaining and that you enjoyed the other ones as well, and thanks for watching.